Projectile motion is motion that travels in a curved path. There are two main types: objects that are thrown horizontally or objects that are launched at an angle. You will still be using the 4 kinematics equation from 1D motion. In the y direction, the equations are still y is equal to v naught t plus 1/2 gt squared. You have v final equals v initial plus gt. You have v final squared equals v initial squared plus 2 gy. And you also have y is equal to 1/2 v final plus v initial times t. In the x direction, you only will have one equation because in the x direction, we have no acceleration. Since there is no acceleration, the 1/2 at squared becomes 0. So x can be written as v naught t. Since v naught is constant, we could rewrite this equation as x is equal to vxt. So in the x direction, x equals v naught t is the only equation. In the y direction, you'll have all 4 equations. The only thing they share in common is time. The time that it is in there to go across in the x direction is the same as the time it takes to go up and down. In the horizontal motion, objects are thrown horizontally. Since there is no acceleration, Vx is constant. So if the object is thrown with a velocity Vx at t 0 seconds, a second later at t equals 1 second, my vector is still the same. Why? Because there is no acceleration. So the Vx is the same length and direction. At t equal 2 seconds, my Vx is still the same because there is no acceleration, so my Vx will not change. And at t equals 3 seconds, my Vx is still constant, so it will be horizontal with the same magnitude and direction. Since the object is thrown horizontally, it only has velocity in the x direction, so my y direction starts at 0 meters per second. However, each second, it will gain approximately 10 meters per second because the acceleration in the y direction is due to gravity, which is 9.8 meters per second square. So at 0 seconds, there is no velocity. A second later, we will have some velocity in the y direction. A second later, at 2 seconds, my velocity will be doubled because my acceleration is 9.8 meters per second square. So that means each second it is gaining 9.8 meters per second. At t3, my velocity will be 3 times because it gained approximately another 10 meters per second. When you solve for projectile motion, it is nice to make a little table. In the x direction, the variables that will be present are x, vx, and t, because there's no acceleration in the x direction. In the y direction, you'll have y, v naught y, vfy, g, and t. This stone is thrown horizontally at 8 meters per second. That tells you the Vx is equal to 8. From a cliff that is 78.4, that is my y. How far? So we are looking for x. From the base of the cliff does the stone strike the ground. So if I draw a picture, pictures always help. We have a Vx going across. This Vx is 8 meters per second. My height of my cliff is 78.4 meters. And what I want to do is find the range or the distance from the base. So this object, the stone, is thrown horizontally. So when it comes, it's going to take a trajectory and land somewhere out here. So we know in the x direction, our equation is x is equal to vxt. But we have two unknowns. So what we need to do is use a y equation and solve for the t to plug in. Since this object is thrown horizontally, the initial velocity in the y direction is 0 meters per second. So the equation I want to use is y is equal to v naught yt plus 1/2 gt squared. Since it's thrown horizontally, my v naught y is 0, so that cancels out. My y is 78.4 meters is equal to 1/2 9.8 meters per second squared t squared. So if you arrange this and solve for it, t is equal to 4 seconds. If you notice, I made y positive and I made gravity positive because they are going in the same direction. If you choose to make gravity negative because it is going down, you must always make y negative here because y is below our starting point. So in general, to make less errors, if they are going in the same direction, make everything positive. If they're going in opposite direction, make one negative. Now we found time. Time is equal to 4 seconds. That tells you the time in the x direction is also 4 seconds. So my equation in the x is equal to vxt. My velocity is 8 meters per second times 4 seconds. So my range is 32 meters. In this problem, again, I'm going to start with the table. A girl jumps off a platform. Horizontal velocity is 2.8. So I'm going to fill the table up 2.8 meters per second. It lands in the water 2.6 seconds later. How high? So we know we're looking for y. So if I draw my picture, this is what it looks like. We're looking for y here. She launches off with a Vx of 2.8 meters per second. Since she is going horizontally, my v naught y is equal to 0 meters per second. And since we are on Earth, we already know that gravity is 9.8 meters per second squared. So if I want to find the height, the equation I want to use is y is equal to v naught y t plus 1/2 gt squared. I already know v naught t is equal to 0 because it's launched horizontally. So this part cancels out to 0. So then this becomes 1/2. This is 9.8 meters per second squared. And my time is given as 2.6 seconds squared. If I do my math, I will get approximately 33.124 meters. If you notice, again, I make gravity positive, so that means y is positive. So at this point where the girl dives off, it is 33.124 meters below. In the second part, it asks for how far from the base, so we are looking for the x here. We know in the x there's only one equation because there's no acceleration, so this becomes 2.8 meters per second times 2.6 seconds, which is equal to 7.28 meters.